In this video, you will learn to add and subtract decimals. You will also learn how to estimate the sum or difference of two or more decimals. And in addition, we will learn how to understand and apply addition properties. So beginning with adding decimals. And I guess with adding and subtracting, the rules are basically the same as when you add and subtract with a regular whole number. So for example, if you had 5.4 plus 2.7, when I set up the problem, just make sure that each place value is lined up. So for example, right here, you would line it up like this, where you have the tenths place, the 4 and the 7 lined up, and you have the units place, or the ones place, the 5 and the 2 lined up. And the addition is exactly the same. We do 4 plus 7 to get 11, so we take the 1 and then carry the 1 to the ones place. Then we add 1 plus 5 to get 6. 6 plus 2 is 8. So my solution is 8.1. So the decimal point would stay right where it was. So it was between the ones place and the tenths place. And again, when I add together, the decimal point stays right there between the ones and the tenths place. Let's try another example. Here we have 12.69 plus 7.5. Now when you set this one up, we begin with the 12.69. And then again, remember to line up the different place values. So the 7 right here, that is my ones place, right? So when I line it up with the 12.69, make sure it's lined up with the ones place here. So the ones place for 12.69 is the 2, so the 7 lines up with the 2. And then you have 0.5, 5 is the tenths place, that lines up with the tenths place for 12.69, which would be the 6. And if you want, you can put a 0 at the end of 7.5 to show that there's 0 in the hundreds place. So now when I add, I'm going to add from right to left. So we do 9 plus 0 to get 9. 6 plus 5 is 11. So we take the 1 and then carry the other 1. Now we have 1 plus 2 plus 7, which is 10. So we take the 0 from 10, carry the 1. Now we have 1 plus 1, which is 2. And the decimal point stays in line with where it was, which would take it right here. So my solution is going to be 20.19. Now for subtracting decimals, the rule again is the same thing. So if you had 5.4 minus 2.7, for example, again, when I set this up, make sure that we line up the ones place and the tenths place. So when I set up, it's going to look like this. So the 5 and the 2 are lined up because those are both in the ones place. The 4 and the 7 are lined up because those are both in the tenths place. And I subtract like normal. So I work from right to left. 4 minus 7 does not work because 7 is bigger than 4. So I need to borrow from the 5. So the 5 becomes a 4. And the one that I borrow goes over here with the 4 in the ones place. So now we have 14 minus 7, which is 7. And then 4 minus 2, which would be 2. And the decimal stays right here to get 2.7. So my answer is 2.7. Now another example, if we had 12.69 minus 7.5. And again, when I set up, make sure that everything is lined up. So we have the 12.69, and then 7.5 to line it up. The 7 is the ones place, which lines up with the 2, which is also in the ones place. Decimal goes here, and the 5 is in the tenths place, so it's going to go right below the 6, which is also in the tenths place. And then if I want, I can add a 0 at the end of 7.5 to show that we have 0 in the hundreds place. So this is my setup, and the subtraction process is exactly the same. So we just work from right to left. 9 minus 0 is 9. 6 minus 5 is 1. And then 2 minus 7 doesn't work. So I borrow from the 1. It becomes 0. And the one that I borrow goes here with the 2. So it becomes 12 minus 7, which is 5. The decimal stays lined up which would put it right here. So my solution is 5.19. Next, we're going to learn how to estimate by rounding. And we've done this before with whole numbers, and the process is the same with decimals. So for example, if you were told to estimate 18.5 plus 45.63 by rounding to the greatest place, what I do is I look at the greatest place for both numbers. So for 18.5, that would be the 1 right here. So to round the 1, we look at the number after, which would be the 8. And because it is 5 or bigger, the 1 would round up to a 2. So this would be a 2 followed by zeros. So we have 20.0 or just 20, same thing. And then the second number over here, we need to round the 4. And to round, we look at the number after, which would be the 5. And because this is 5 or bigger, I round the 4 up to a 5, which makes this 5 followed by zeros. And it's going to be 5, 0, and then 0.00. But no need to write the zeros after the decimal point. So this would be just written as 20 plus 50. And we would say that this is approximately 20 plus 50. So that symbol is my approximate symbol. And then we do 20 plus 50, and that gives me my estimation of around 70. So my rounded answer would be 70. Next, for subtraction, if we had 62.413 minus 25.1. And again, we are trying to round or estimate by rounding to the greatest place. What I do is I round the 6, and to do that I look at the number after, which would be the 2. So to round, the 2 is less than 5, which means the 6 would remain as it is. That's going to be 6 followed by zeros, which would be 60. And then for 25.1, I need to round the 2, and to do that I look at the number after the 2, which would be the 5. So because 5 is 5 or bigger, the 2 would round up to a 3. So we have 3 followed by zeros, which would be 30. So we have approximately 60 minus 30, which would give me my estimation of 30. So my rounded answer would be 30. And by the way, again, when I'm rounding, unless it specifies otherwise, you want to round always to the greatest place. It might say round to the nearest whole number or round to some other digit, and if it specifies, then you would round to that place. But if it does not specify, make sure that you're rounding to the greatest place value. Now here's an example where we are estimating by rounding, and we are asked to round to something other than the greatest place value. Here we are rounding to the nearest whole number. So the nearest whole number, that means we're rounding to the ones place. So we're rounding the 8, and then we're rounding the 5. And to round both of those, we look at the number right after it. So the 18.5, to round to the nearest whole number, I look at the tens place. So for 18.5, we look at the 5, and because it is 5 or bigger, the 8 would round up to a 9. So this would be 19.0 or just 19. So we have 19, and then the second number, we look at the 6, and the 6 is 5 or bigger, so the 5 would round up to a 6, which would make this 46. So what I have is approximately 19 plus 46, and when I add those, we work from right to left. 9 plus 6 is 15, so we have the 5 from 15, and then carry the 1 over here. 1 plus 1 is 2, 2 plus 4 is 6. So my final rounded answer is going to be approximately 65. Now to finish off this lesson, we want to work with some different addition properties. So the first addition property is called the commutative property. So in English, the word commute means to move or to travel. So you or your parents might commute to work each day. Commute means to drive or to move to work. So the commutative property is the same concept where it's dealing with the moving of numbers. So for example, if we have 5 plus 6, it doesn't matter if we have 5 plus 6 or if we move the numbers around and have 6 plus 5. Those are the same things. So the commutative property says that the order of addition does not matter. I can move the numbers around. So that would be an example with actual numbers. And in general, in math notation, we would say a plus b would equal b plus a, where a and b are any number, and it doesn't matter if the a comes first or the b comes first. And again, in English, this property says that when adding, the order does not matter. Next, we have the associative property. The associative property, we look at the word associate in the word associative, and this has to do with how we associate different numbers together. Now, when we say associate in English, that means kind of how you group something. So for example, you might associate with certain people. That means you're part of that group, right? You group yourselves with those people. So the associative property has the same idea, where what it says is that it doesn't matter how I group together or associate the numbers when I'm adding. So for example, if I had 4 plus 5 plus 6, we could group the 4 and the 5 together and add those first to get 9 plus 6, and that would equal 15. And then that's the same thing as if I were to group together, instead of the 4 and the 5, we group the 6 and the 5. So if we group it together like this, we would do parentheses first. So we'd have 4, and then 5 plus 6 would be 11. So 4 plus 11 would also equal 15. So we have proven to you that it does not matter how I group or associate the numbers together. So that is an example. And in general, we could write it like this, where instead of using actual numbers, we can use the letters A, B, and C. So we can group together A and the B when adding, and the C would be outside of parentheses. Or we can group the B and the C together, and the A is outside of the parentheses. So in English, we could say this as, when adding, the grouping does not matter. And when we say grouping, what we mean is the parentheses. So it doesn't matter how we put the parentheses together. It doesn't matter which numbers we put in there when adding. Another addition property is what is called the identity property. So the identity property says in English that there is a number that we can add to anything that will not change the identity of the original number. And that number that would do that would be the number 0. So for example, if we do 5 plus 0, the 0 being added does not change the original number. We started with 5, we add 0, and we still have 5 as my answer. So the identity property says that I can add this number 0, and it does not change the identity or the value of the original number. So in general, we can say A plus 0 equals A, where instead of using an actual number, we would use the letter. So this would be the same thing, just in general. And again, in English, we can say that adding 0 does not change the original number. This is the identity property. So next we're going to do a little exercise where you need to identify the addition property. So you need to determine if we're looking at the identity property, the associative property, or the commutative property. So here we have 8 plus 0. Now this would be the identity property, which says we can add 0 without changing the identity of the original number. Next, we have this expression. So this one, be careful, because we see parentheses here, but let's look at what's actually happening. Inside of the parentheses, right here we had 5 and 9. Over here we have, again, 5 and 9. The only thing that's changing is the order of the addition. So the grouping is still the same. We still have the 5 and the 9 grouped together inside of parentheses. But what is changing is that the 5 and the 9 are being switched. So the order of the addition is changing. So this one would actually be the commutative property because numbers are moving. Whereas this next one, we have 6 plus 5 plus 9 equals, and then 6 plus 5 plus 9 with the parentheses changing. Notice the grouping is different. So here we had 5 and 9 grouped together. Here we have 5 and 6 grouped together. So the grouping has changed, which would be the associative property. And then lastly, we're going to apply the different addition properties. So we can use these properties of addition to make our lives a little bit simpler when we are adding. So for example, here we have 12 plus 4 plus 18 plus 16. So we could work from left to right and get our answer, but it's going to be easier if I can maybe move things around and group things together. That would be easier for this addition problem. So for example, if I take a look at the 12 and 18, so let's put the 12 next to the 18, and then the 4 we'll put next to the 16. So we use the commutative property to move the numbers around. And then what I can do is I can group together the 12 and 18, and then the 4 and the 16. This would be my associative property that says I can group the numbers together however I want. And now, the 12 and 18, I chose to put those together because when I add 12 plus 18, that's going to be a quick one to do because that's going to give me 30. So that gives me 30, and 4 plus 16 is 20. So we have 30 plus 20, which would give me 50. So my solution is going to be 50. And yes, we could have worked from left to right and gotten that same number, but it would have been more difficult to do that in your head. So it's going to be helpful if we know and can recognize the commutative and associative properties to make our lives a little bit easier as we work with addition. And that concludes our lesson for today. We will see you next time.